simply saying that your team is, using AI and at this rate and this many, whatever, you do this many calls, this many queries per week or per month is not enough because there's a big difference in like the way you use this stuff.
Hello, and welcome to HangarDX podcast. This is a podcast about developer experience and how engineering teams solve productivity challenges at scale. So today we have here Igor with us, joining in from Stanford Research. One of his recent talks about ghost engineers also became very popular. So we're going to talk a little bit about that, but we will also cover some other topics on productivity. I'm your host, Ankit, co-founder of Aviator. At Aviator, we build a lot of like developer productivity tools, including multiplayer AI coding platform that helps you share some of the best practices and learn from each other. But before we get started, Igor, I'm really excited to have this conversation. Thanks for making time. Can you please introduce yourself for the audience?
Ankit, thank you so much for having me on the podcast. It's a pleasure to be here. A bit about my background. I self-taught myself how to code when I was 14. I dropped out of eighth grade, started a company, was the kind of solo developer there, somehow made it work. Fast forward a few years, I had a career switch, was a competitive athlete first for a while, and then fast forward even more years, I was working at a large company looking after what we called digital transformation, which is basically how to make decisions or making decisions around our thousands of software engineers. And the problem that I ran into is that we didn't really have any good data to make the quality of decisions that we wanted to. And so then following that, I came to Stanford. And for the past 3 years, I've been researching software engineering productivity. And now this is a super hot space, especially because of how AI is disrupting the whole field.
Amazing. So, given that we have very short time, I'm going to dive straight into the topic, Igor. Why don't we start a little bit with your research methodology? So many folks do different types of research. For instance, Dora is completely based on surveys. Some are based on completely like analytical data, sort of like coming from systems. Give us a little bit overview of what has been your typical approach at research.
Yeah, I mean, there's many ways to measure developer productivity or developer output. We like to call it developer output to just kind of narrow it down a bit more. And our hypothesis is that everything a software engineering team does will eventually, in one way or another, be seen in the source code. Even the stuff that you do before writing code or after writing code eventually kind of is reflected in that source code. And so we have plenty of metrics that are upstream of the actual kind of code, right? And also downstream. But there's a bit of a black box around kind of what happens in the actual source code. And there's all these existing metrics, like kind of lines of code and commits and PRs and Dora and whatnot, surveys as well. They are somewhat useful for certain things, but in our opinion, they had a few kind of limitations around measuring output. And so a way to solve this, not solve this, like it's a way to measure something different. I think it's different and in some ways also has limitations, is that we take a panel of human experts who independently evaluate the source code changes that are done in every commit. And this panel is kind of senior software engineers who have context on the repository they're evaluating. And then this panel would look at the commit and assign labels to that commit based on 3 or 4 questions, such as implementation time, code quality or maintainability, and complexity of the problem being solved. And so then in doing this, we kind of trained a machine learning model, which essentially replicates this panel, allowing us to do this at scale. So like in a bit of a nutshell, that's basically what we do. Look at code, have humans rate the code, build a model, which then replicates the human.
That's very interesting. Like this is a definitely a new approach that I've not heard of before. How do you avoid biases in, both? There's two aspects, right? You were picking the experts and you're picking specific commits, right? Like for doing sort of evaluation or like training, whatever. Um, how do you avoid biases in that selection?
Yeah, it's a good question. I think we are probably unable to avoid biases entirely because anytime you use a panel of humans, you are going to have some form of implicit stuff in there. But in general, there's 2 ways. The first one is if you select more than 10 or 15 humans, you can kind of adjust for someone who's a bit pessimistic, someone who's optimistic, someone who likes things being done in a certain way or the other way. And what we found actually is that in selecting a panel of 10, 15, 20 experts, there's typically a pretty high, what's called intra-class correlation coefficient, which means how much does the panel agree with one another, right? When someone says that code is high quality, how much does the next person agree with that statement? That's kind of like one dimension. And the second one is that you can just repeat this exercise across multiple languages and using different panels, right? Different permutations. And eventually you develop a bit of a distribution, which you can then kind of extend, kind of like interpolate between two data points, basically. And this gives you a place where even if you don't have all of the cases, you can kind of roughly predict what are the missing gaps. And, it actually works quite well. There's a few places where it kind of gets confused a bit, but, I think all of this is addressable. And, potentially the whole methodology of just kind of having humans reviewing commits and then training a model to replicate those humans is quite good. And potentially there's, still a lot of room to improve on the methodology and on the model itself and whatnot because of the heterogeneity of software engineering, right? There's just like so many different languages, ways of working, uh, things, problems you're solving, and all this kind of stuff that it's a bit of a challenge for sure.
Cool. Okay. So let's first dive into one of your earlier research, which was around predicting expert evaluations on code
Mhm.
reviews. So can you share a little bit about your learnings from that, and then we can kind of dive into more specifically, uh, what can people take away from there?
Yeah, so this was basically what I just explained. It's like that paper is basically like an early version of what I just explained. So you have humans that look at commits and they evaluate those commits. And we did a few mistakes, just being objective in that first paper. Um, Nothing too critical, but definitely lessons learned, which we've improved. Kind of like on the subsequent training runs. And of course, in publishing the paper, we were very intentional around also publishing the stuff we didn't do quite well. And probably the biggest thing, which isn't a big deal really, is that we realized you can't really predict seniority based on code.
Mhm.
So it might not be a surprise now retrospectively, but kind of when we were in the moment, think 2.5 years ago, we were like, hey, let's kind of test this. The second thing we did was that actually also we kind of tried having people rate or put commits into buckets, like, hey, relative to all the code you've seen, where does this commit kind of rank? That was not a very good methodology because everyone's like there's too much distortion on an individual basis to make that useful, right? So those are kind of the two things that I think we can improve on, which basically means just like don't have raters answer those questions. And then of course there's been a whole bunch of work done around kind of improving the model and training and kind of expanding it to different languages. This initial paper was very intentionally of a very limited scope. I believe it was 70 commits only with 10 humans answering, I think it was 7 data points. So like about 5,000 data points. Not enough to kind of like generalize, but enough to make it be like a proof of concept. And then from that, we kind of did further training runs across different languages. We work with real companies and real data. And so this is really important. You cannot really do this type of calibration if you use public repos because the way you write software and commits essentially in public repos is a bit different than the way you would do it in a private repo, right? Where there's like a bit of a whole different environment that you're operating in.
What was like some of the initial assumptions or expectations from this research, and was there anything surprising that came out of it?
Well, based on this kind of first paper, we had a methodology, a way of then measuring developer output,
Mhm.
which then enabled us to reach all kinds of or do all kinds of analyses around like people's productivity and like remote versus in office working or like impact of COVID. That was like some of the earlier work done in kind of 2022, 2023. That was still kind of relevant back then. Of course, now it extends also to the impact of AI, right?
Mhm.
And in general, I would say that work is more like foundational to enabling further work. Of course, it can be improved, and I think it's actually extensible to other knowledge kind of worker domains, meaning that you could probably use the same methodology to evaluate another type of skilled kind of knowledge worker, right? The problem is that for software engineers, a lot of the work we do can, as I said, it's there's great telemetry around it, and it all ends up kind of being reflected in Git. So it was like a bit easier to start this exercise. But I hope that, someone else kind of builds on this work either in this domain or also in like other domains, because I think the methodology, like I've discussed this at length with several researchers, professors, and they're like, yeah, I think this is like pretty solid and has like a lot of merit to it. So, still a lot of work to do, I would say.
I mean, we'll definitely get into also this whole challenge of measuring productivity itself, but like just kind of like picking up on the thread that we talked, you mentioned about AI, and also specifically like the research work came out 2 years ago. So maybe you can share two parts. One is how can we use some of these concepts for measuring the impact of productivity on using AI, and second is kind of like how has this research evolved? What have you kind of like uh, what has happened in the last 2 years to kind of reflect on that?
Sure. So we were fortunate to start this research right before the ChatGPT moment in November of 22. And for the first probably like 6 to 9 months, we also weren't super focusing on AI just yet because AI was still very novel. Its uses for software engineering were quite limited. I think you had GitHub Copilot at the time, but honestly, it was more like a fancy autocomplete. I mean, it still kind of is, but it was just like way less mature. I remember using it in October of 22, and for some stuff I was doing in Python, it was debatable how good it was. It was like a nice little tool, right? But of course, it has progressed a lot, and it's actually quite useful now. So then since we plug into Git, we can go back in history and kind of see what the impact of AI is on developer productivity. The way we do this is by putting people into cohorts. So basically, we know when a person started using AI. We also have telemetry around their level of usage and kind of what models, tools they were using, right? And so then based on this, we can kind of do a before and after analysis for the same cohort, or otherwise we can find software engineering teams who are very similar to one another and run what's called a difference in differences analysis. So here what you do is you kind of take two teams that across, X number of attributes, in our case we picked I think 7 or 8, they show similarities, right? And so what this allows you to do is compare apples to apples rather than apples to oranges. But I must say that it's still kind of like red apples to green apples or so. So there is like a bit of a difference. And of course, there's a bit of statistical artifacts that happen. And you kind of grab these two teams and you give one of them, well, not give, it's just like one of them uses AI and the other one chooses not to use AI, right? And then you can track them across time. And so early on, for the first, like probably until early 2024, we weren't really seeing a lot of impact on productivity. It was hard to discern it from the noise. And there's kind of two trends. Right now, the median impact we're seeing is closer to 10 to 15% in lift, which is very different to some of the numbers that were published. I think, there was a study by GitHub/Microsoft in 2023, which claimed 60% lift in developer productivity. I'm not sure how well that aged, but I think 2 years after that, I guess I can leave the audience to decide whether that was the case or not. But where we are right now is that like 10 to 15% lift, and most importantly is that we're seeing a very big difference between the teams that know how to use AI and the teams that don't, right? So in that kind of apples to apples comparison, those apples that know how to use AI are seeing 20, 25, 30%. Those that don't are seeing, 0 to 5%, and sometimes even a negative. And then the second effect that I want to talk about is also there seems to be a skill, like a learning curve in using AI tools, and that the first, 30, 60, 100 hours, depending on how you define an hour, right, of usage, people actually see like a slowdown in their productivity, and eventually kind of like it reaches parity and you start getting the lift. My understanding is that it may be more around people start to understand when they can use and should use AI for kind of what commits and what tasks within a PR they can use AI, and for what tasks they should not use AI because it's too complex or whatnot. So that's kind of like one interesting thing. The second thing is that, and this we cannot measure too well, admittedly, is There seems to be a bigger impact, like AI seems to be kind of impacting the parts before and after, like in the software development life cycle, kind of like the stages before you actually do the coding and after you do the coding seem to be getting a lot more of the impact than in the actual coding itself, which seems a bit counterintuitive, right? And so we cannot measure that super precisely, but in experiments that we've ran, whereby we kind of freeze variables and do this kind of stuff, kind of like to see the impact of different things, it definitely seems to be much more lower hanging fruit in kind of the whole, specs and product requirements, kind of like getting knowledge in a repo and how does my task fit into the repo I have in front of me and that I'm working with, right? And also kind of like around QA and debugging and kind of digging around and searching more so than kind of writing the actual code, if that makes sense.
Interesting. What do you think about the delivery pipeline itself? Like once code is written, have you seen any kind of like impacts on? I mean, obviously, like code reviews tend to be one of the bigger bottlenecks, but like also there is like whole CI and CD and observability and maintenance. Has any of your work or research shed light on that too?
Not really, because we kind of focus a lot on essentially Git and commits and PRs, right? Not by counting them, but rather by measuring and quantifying. I don't want to call it value, but let's call it value. It's not exactly value because value implies like, a dollar amount, which isn't exactly the case. That starts getting into more of a product problem, right? But we kind of like, let's call it value. We measure the value of the commit rather than counting lines. And if a commit has like very few lines but is high impact, then that will get scored higher than if a commit has like a ton of lines but is super low impact. And because of all this stuff that's exogenous, meaning sits around the task of writing code, it kind of ties in indirectly, but we cannot really isolate it too well. And so something that we're working on is I talk to all these kind of CXOs at different companies, and they all have the same question. They tell me, Igor, we've deployed AI, we've committed budget. Our team likes it for the most part. There's a few quirks, but we don't really know how to quantify this. We don't really know like exactly are we doing like where are we relative to other companies? Are we getting the same effect for all parts of the company, right? And how can we use data to also improve, learn, and get better? Like it's almost like you just spray AI and then pray that your engineers figure out how to use it, right? And so to answer that question, because I think there's no obvious it's still early days, despite us being almost, what is this, 3 years in or so into the whole AI, mainstream phenomena. There's still no playbook, no obvious answer. It's like, okay, well, yeah, you should probably buy, some of these AI tools, tinker with them, but it changes so much that there's no way to evaluate this impact. And what we're working on at Stanford is kind of hopefully coming up with this open source replicable way of evaluating the impact of AI on engineering productivity for deployments in larger enterprises. We're going to start piloting this in kind of real companies to see how they like it. And eventually if there's, we might adjust a few things, but we expect to kind of have a paper out at some point early to mid-year or so, which I'm really excited about.
Very cool. Amazing. Switching gears a little bit. I mean, we talked about developer productivity, and there's a forever debate about it. People say, okay, not everything is covered in Git commits, and I think you kind of like already shed a little bit of light on this. So, how do you think about like accounting for things like mentorship, architectural decisions, meetings, code reviews, other invisible contribution, if I were to kind of like call it that? Generally, we say senior engineers, staff engineers, they write more docs, they write less code. So how do you kind of like think about these aspects when it comes to the developer?
The reality is that if I'm a super senior engineer and I'm more of an enabler, meaning that I do kind of more code reviews and documentation and architectural decisions and less bread and butter coding, let's call it this way. In terms of the output I am delivering myself as a software engineer, right? The kind of pure output, there's attribution problems because a lot of the work I do is enabling others. And then of course in Git, we, basically have one max, just let's call it for simplicity's sake, one author for each PR, right? Even though there might be other people contributing to that PR. Let's not get into kind of whole whatever merges and all this kind of stuff. And so what we like to do is to measure at team level. right? So kind of measure how the team is working, measure how many enablers to coders you have. And by enablers, I don't just mean kind of architects or whatnot. I also mean kind of product managers and QAs and business analysts and other people that are supporting you or the engineering team in doing their role. And then there's actually a significant difference in the ratio of like, let's call it enablers to coders across companies, which is kind of counterintuitive, right? Every company kind of has their own. It's not so much about the headcount allocation; it's more so about the dollar allocation, if that makes sense.
Okay.
And so I think there's like interesting information there. But overall, I think that yeah, look, myopically measuring output, like you shouldn't probably use our model to determine whether a senior engineer is high performing or not, and you shouldn't use our model in isolation with anything, right? It's like a tool that gives you a different view which should be combined with potentially other tools and other views, but most importantly with context and with information about the team. But overall, in terms of measuring it at team level, it's actually a pretty good way of measuring it. The question that comes up is that, well, a team could be slowed down by decisions that are exogenous outside of the team. And how is that the team's fault? And that's like a separate topic, which is that just because a team is moving slow, it doesn't mean it's that team's fault, right? It could be many things. And the conclusion of a team moving slowly isn't that the team is poor performing. It's that all the conclusions you can make is the team is moving slowly. That's it. Now, there might be things that the team can do better themselves to move faster. Yes, that's true. But there's probably also things that those working around the team could do to help the team move faster, right? This could be changes on the people side, on the process side, on the kind of like, just ways of working, tooling side, right? So there's like all these different things, and where people sometimes will get into trouble is when they use tools like these or methodologies like these to kind of myopically measure one person and then like really over fixate on that, when you should be kind of like take a step back, put that into context. And also if the team is not performing, like ask yourself why, dig deeper and kind of figure out what's happening and what are the blockers, right? And then like talk to the team, let's see what they say, and then kind of address the blockers and see if the performance goes up or even if the blockers kind of make sense, and then kind of take it from there. And the third thing I will say is that sometimes there's just a genuinely good reason for teams to move slower. There is a trade-off between kind of speed and quality. And now the third dimension we're adding is kind of like rework, which is implicitly tied into both quality and speed. We've worked with many teams who are like, look, we know we're moving slower, but our product is mission critical. And we would rather kind of move 30% slower and kind of do things right than kind of start pushing harder and then have our product kind of go down or have things not working, which then is going to cost us way more than the 30% that we're kind of foregoing on moving a bit slower, right? And so I think I'm a big advocate of that. Don't just push for speed, speed, speed. Consider quality, consider the impact on the business, right? It's not just about how much things you're building. It's also like, what are those things doing and how do they enable or not enable the business to achieve its outcomes?
Right. Yeah. I mean, it always reminds me one of the examples of one of our friends from HangarDX, Brian Finster, talks about building software for nuclear submarines. If you're building software for that, you cannot take any corners. You cannot cut any corners.
I think in those cases, you could kind of measure yourself against the past and then kind of see how you're doing against the past. What's really interesting in our methodology is that we can benchmark companies against the industry, against the global population of research participants. And what you'll see is that maybe like if you're kind of a YC startup and your code base is 10,000 lines of code, you're going to move much faster. And you have like whatever, 2 engineers, 3 engineers, you're going to move much faster if you are allowed to kind of focus on coding, which is another thing that startups, it's not taken for granted. But typically, you're going to move much faster per hour spent than like a large enterprise where there's kind of an existing, set of whatever things you need to account for, both on the people front, on the tooling front, on the legacy functionality front, on the infra front. All these things can slow you down, right?
You don't have to name names, but I'm curious if you've seen any large enterprises where you felt they were moving fast. And maybe if there was like any pattern that you could relate that to.
Yeah, for sure. I think there's kind of like the speed between enterprises, which is one thing, but typically within an enterprise, you will have teams that move really fast and teams that move really slow.
Hmm.
And some of that difference in speed is justified, or meaning it's explainable by their differences in whatever product maturity, code base, maturity, all this kind of stuff, team size. But oftentimes, what I think is really interesting is as a company, especially in this era of AI, a lot of the productivity gains you're going to see is basically people experimenting and figuring out ways of doing things. There's no playbook. There's no consensus around anything, right? Like even every 2 months, the best. I mean, I guess that's been the case for the last 2 months only, but the best, let's say, language model for coding assistant kind of keeps switching, right? I think before that. Without naming vendors, I think there was one which people typically liked more. But as of the past couple of months, I think I've personally been kind of switching more towards another one, right?
Yeah.
So there's no playbook, and a lot of the learning is going to be just like internally based on other teams. And so I encourage leaders to kind of look inside their organizations and just kind of look at what those teams that are just more inclined to learn and move fast and kind of experiment with things and extrapolate those learnings and kind of cross pollinate those learnings to other parts of the org, right? Which is kind of the way things are going to have to be until we reach some kind of like more industry, more consensus around kind of what to do and what not to do, specifically using AI, right? What we see in the data is that there is a divergence between the top performing teams and the bottom performing teams, meaning that those teams that know how to use AI have like this the rich gets richer effect, meaning that like those teams that know how to use AI and henceforth are quote unquote rich, right, will continue to compound their gains, whereas the laggards are going to kind of stay behind. At some point, though, that divergence is going to converge, meaning that the gap is going to close once we figure out kind of playbooks, ways of working, and whatnot. But I don't expect that to be in the next 3 years. I mean, we're 3 years in, yes, there's been improvement, but like we hardly know what the hell is going on, to be honest. So I think it'll be like another 3 to 5 years before things can mature and stabilize a bit more. It's still relatively early days, and
Interesting.
experimentation within a company is interesting. But maybe like the just circling back to your question, what I see companies do well is typically three things. Firstly, is that they don't just deploy AI and track usage, but they track how is that usage, like what are the results of that usage. Simply saying that your team is using AI and at this rate and this many whatever you do, this many calls, this many queries per week or per month is not enough, because there's a big difference in like the way you use this stuff. Secondly, is that top performing companies, I see them more and more use AI across the entire software development lifecycle, not just kind of in your IDE and kind of coding assistance, but also kind of in the stages before and after, right? Like just like across your CI/CD pipeline, basically. And they're just thirdly more they treat AI like a scientific experiment. They have hypotheses which they test, they measure, they have metrics, they can track, they make decisions, and they are disciplined about using AI for certain things and not using AI for other things. The problem there, though, is that every 3 months, capabilities change, emerge, transform, and you just need to continuously be kind of trying things out and learning, because stuff just like changes way like very fast, right? I guess word in the street is that there's like a bit of a plateau on the kind of like a large language model front. I mean, TBD how you define plateau, because I think a lot of the well, let's not get too into this world yet. But my point is that even if the capabilities of large language models plateau, there's still unaddressed capability gaps in the tooling and in the way you use these LLMs, which are going to continue to offer gains in the future, right? And so, even if kind of like the base model in itself is not by itself in isolation offering gains in performance, you can still kind of do the way in which you kind of use the model. This can be anything from kind of inference time to scaffolding to different agents to whatever, all this kind of stuff that you can do with it. You're using the same model at its core. You're just kind of like combining it into different permutations and having it do different things. I think we still have like a lot of runway there left, a lot of experimentation, a lot of potential.
Okay. So essentially, you're saying is with AI, sort of like the success rate. A way to get better at AI is by being very thoughtful about how you use it and measuring
I mean, it sounds very honestly dumb, but I see companies that are like, wow, Igor, hey, we deployed AI and like we don't know what to do next. Like, okay, we are an AI company now, AI enabled company. And I'm like, well, great. So what are you doing? Well, we bought everyone a coding assistant license and then we are playing with a few tools up and downstream and then that's it. Like, we don't know what to do next. And it's like, well, you have to kind of, honestly, the answer is nobody really knows. You have to just like experiment and treat things like an experiment but like really double down on this, right? There's been a lot of chatter around early on this year. A certain CEO mentioned how by September it would be like writing 90% of the code with AI. That's maybe not the case. Another certain CEO hinted that they would be replacing their mid-level engineers by the end of the year. In reality, what happened is that their headcount increased by 11% year over year around engineering. And so it's like they say one thing publicly to keep their stock price up and to kind of buy into the hype train, but internally they do other things, which I find really fascinating. And I'm not criticizing them. They're doing their job and they're kind of, I guess, creating shareholder value. It's just that, the way you read into these announcements of different CEOs has to be taken with a grain of salt. I would encourage people to look into what is the agenda behind people that make these claims. Are they part of a company who benefits from kind of hyping AI up, be it in their stock price and their funding round, whatever it is? Or is it someone who kind of honestly doesn't have much skin in the game and yet is still like an expert in the space? And I would kind of encourage people to skew towards those that don't have as much, at least financial skin in the game, but a lot of kind of like knowledge and, they're close to the work without directly having hyping AI be part of their literally job responsibilities, which is kind of like what basically boils down to many CEOs nowadays. When a journalist asks them like, hey, I heard that X company is getting X percentage in productivity in AI, right? Gains in AI. How are you guys doing? If you say, actually, AI is a tool and like we're learning and we're exploring, your stock price is going to tank. So of course everyone says, oh yeah, we're killing it, 1,000% gains. We're replacing everyone with AI. Everything is going to be great. We're going to, AGI next year. So,
Yeah.
I could, it's not sure it's super healthy for the industry actually, because what it creates is that CXOs of other companies who use engineers, they take these comments at face value and then they pressure their CTOs to, hey, this person said they're replacing their engineers with AI. They're writing 90% of their code with AI. Where are we in that journey? And there's like a disconnect, and it puts lots of CTOs into trouble, frankly speaking. And I think it's tough for them out there because they have to navigate this. Like, how do you tell your boss essentially as a CTO that actually, yeah, this thing that you know certain CEO said is a bit overhyped and like we're not there yet, not because I'm not a good CTO, but because the technology is not just there. And so it's a tricky
Okay.
domain basically.
I know we can go on for this forever, but I do want to at least cover your well, controversy might be a little bit too much, but like the concept of ghost engineers.
Hmm.
Um, can you share a little bit about like how did what was kind of like the way you measured that aspect, and maybe just for the audience also, what did you mean by ghost
Sure.
engineers?
Yeah, so let's start with the definition. A ghost engineer is a software engineer whose job and role is to be coding full time or close to full time. So they're not kind of doing sales or they're not sales engineers or anything like this. They're kind of bread and butter engineers and whose performance is basically, I think it's like 0.1x, 0.2x of the median, like pretty low, right? So they're basically doing nothing. And what we did here is we have all this data from companies, and we also have people's in an anonymized way, of course, job titles, and also a confirmation whether a person is a full-time coder or not. And what we found out is that there was like a large percentage of people, in this case, overall, like 9%. I think in the office it was a bit smaller, and and for remote it was a bit larger. That basically were producing very little output, despite the fact that their job is to write code. I think if you were to run the same analysis for any other white collar knowledge worker function, you'd get a similar result. And, I think some people loved it. Other people said, well, this is, I'm not sure if they agreed. The more senior someone was, the more they tended to like it. Like, for example, Elon Musk reshared it. A few other prominent people reshared it as well. And then like those that were closer to individual contributors, they felt maybe perhaps a bit personally attacked or so by it. I will say that potentially there was a bit of a sampling bias present in the way that we work with companies that are concerned about their engineering productivity. And so it's almost like if you go to a patient, to a doctor's office and look at the waiting room and ask people how their health is, you're probably going to get a result that's not very, not very healthy, right? Because you go to a doctor because you think there's a problem. You don't know, but you feel kind of off and you want to confirm. There might be a similar effect here, although, frankly, sometimes we have the opposite effect, which is companies know that they're just killing it in engineering and they want to prove it to their whatever investors, stakeholders, customers, whatever it is. But there might be a bit of that. And secondly, there might be like a few percentage points which you could shove off based on the fact that, well, maybe my job is to code, but I'm not coding because I'm enabling, and yet I'm still like a very valuable member of the team, even if I'm not actually writing code. Despite this, we've validated our results across like different companies, and as our data set expands, like the number stays pretty constant, more or less. And so I have pretty high conviction that like this is a real effect, and that every company, every large company at least, has an opportunity to kind of understand who their lowest performers are and why that's happening, and kind of address that in some capacity, be it by enabling them, be it by whatever method they see that seems fit.
Very interesting. I have a couple of follow-up questions at least. So first is there was this metric, right? 14% of remote workers are ghost engineers versus 6% in office. Now, this obviously has an implication for the whole debate around remote work. Do you have any thoughts on kind of like how people should interpret this?
Well, I think it's part of the data also showed that those that were remote had like a higher performance median, I believe, and a higher kind of performance top quartile. And so the answer is that it's easier to be a ghost engineer when you're remote. You can hide in more places. A lot of these ghost engineers were also overemployed, meaning they were working multiple jobs. So that's kind of like one thing. I think that also if you're remote and everyone is remote, there's just like less visibility. I'm not saying that being in the office is better or worse. If I could pick a work modality, I would say like hybrid would probably be my preferred choice, although I know that's not a fit for everyone. And I think there's, many companies who are fully remote and performing very well, but there is like a lack or a decrease in transparency and visibility around people just like showing up. The other thing is that, well, you can show up but be unproductive or just not do much, or, be even a drag to others. So the conclusion is that it's easier to hide when you're remote, but it's also easier to be really high performing because you get dragged into less distractions and you kind of save your commute. And if you're like a serious and whatever, a person that works well remotely doesn't need a lot of interaction with others, I think it's actually beneficial to do that.
I see. And the second part is around motivation. So there was like also a mention of like, okay, some of these folks become disengaged due to frustration or loss of motivation, and not necessarily like, out of malice. So any thoughts on kind of like, where does this problem really lie? Is it like, okay, do companies need to think about, improving their hiring, or sort of like, is it a management problem? Is it like a cultural problem? What's going on there?
Yeah, there's different ways that this can, like that the ghost engineer phenomenon can happen. It's hard to kind of put a finger on any specific one. It's usually a combination of things. But what's lacking is transparency, it's visibility, right? Regardless of why it's happening, you need to know when is it happening, and that's kind of what's lacking. I'm sure some people do it out of malice. Other people do it out of, let's call it need or whatever, maybe they're working multiple jobs because they have to support. Yeah, like I'm sure that happens. I don't know how frequently. I think in general, software engineers are pretty well compensated, and so unless there's like some very extreme circumstances, which I'm sure there are, but again, prevalence is the thing that I'm unsure about. I've had the privilege of talking to a few of these folks. They reached out at first with threats and stuff like that, very strong opinions. Ended up chatting over email, over Signal, even kind of voice calling, and they were like, yeah, many of them had the same story that like, look, I used to be someone who was excited about my job. I wanted to do better. I wanted to improve. I wanted to grow, to, be part of the team. But for whatever reason, there's like all kinds of different reasons. I just became disengaged. I either saw others that weren't doing much, so I became disengaged. I either saw how my effort was not being either rewarded or recognized appropriately. And then I kind of started to disengage. And as they disengaged, they would see that nothing would happen. And so let's say you go from being like an average engineer to below average to like slightly or heavily below average, and you see that nothing happens. And the reason nothing happens is that also you have to understand like politics play a role here, and middle managers aren't always incentivized to pluck or address these performance concerns. As long as the middle manager is managing up properly and they're delivering on time and there's no questions around like how their team is performing, why would anyone kind of stir the boat and whatever, stir the pot, rock the boat around the performance of their team? And as a manager, you typically want to increase the span of your headcount, which means part of it is appearing as a competent manager, and appearing as a competent manager means that you don't have ghost engineers on your team, and so you're not incentivized to report them, right? Not incentivized to kind of like go through this kind of performance improvement plan process with HR where you document this. It's all like unnecessary as long as you're managing politics appropriately from above, of course, right? And so again, all of this just ties into transparency and visibility.
Yeah.
I
mean, I'm sure like everyone has also heard about the Sohram Parekh incident as well, which was an extreme of it.
For sure.
Okay. All right. So this is probably one of the longest sessions we have recorded. So let's stop here. Thank you so much, Yegor. This was a fun, entertaining conversation. And thank you all for listening. If you're interested in developer experience or working in DevOps platform teams, you can also join us at HangarDX. It's dx.community, where we run virtual sessions and talk to amazing people about many of these topics. And yeah, thank you so much, Yegor, for your time. Really appreciate it. We'll keep an eye out for some of your further research. I will also link some of the reference material in the show notes so people can find some of your work.
Sure, Ankit, thank you so much for having me on the podcast. It's been a pleasure. I encourage everyone to reach out in case they want to chat further. I'm super happy to discuss this at length. Thank you so much.
Awesome.